Hey guys, we're still looking at 11.6, our applications with quadratic functions, but now we're going to talk about x-intercepts. So remember, x-intercepts are our solutions, but we've got to be careful here because our x-intercepts are going to represent time. And guys, time cannot be negative. I cannot go back in time. We're not time travelers. So we may wind up with some negative solutions, and these are not going to be valid solutions. So we're looking for only valid solutions here. So let's look at an example of this. It says a cannonball is shot from the side of a hill. The motion of the cannonball can be described by the equation h of t equals negative 16t squared plus 12t plus 40, where t is the time in seconds and the height is represented in feet. So when will this cannonball hit the ground? Guys, when you see that it says hit the ground and it says when, that is dealing with a time. You should automatically think, oh, this is a time. And if it's hitting the ground, that's going to be an x-intercept. So I need to sketch this out to start with. So I know we're on the side of a hill. And granted, my hills don't look great, but it's fine. And it's going to go off into a flat land. So we've got our hill. And our cannonball is on this hill. So I know it's going to be shot from a cannon. There you go. That is as good of a cannon as I can draw. And I know that it's got some sort of initial height, and we actually can look at that initial height being 40 feet. So I know that this is going to be 40 feet from ground level. But I actually want to know the trajectory of this cannonball. So I know the cannonball is being shot here. It is going to go and it's going to eventually hit the ground. So we've got to find where X marks the spot. We've got to figure out what time it's going to take for it to travel. So we're not really looking at a distance here. We're now just looking at time. So our x-intercepts or x values are going to be dealing with time, while our y coordinates are going to be dealing with a height. Okay? We're not dealing with a distance here. That's what I need you guys to kind of understand. I need to find a time in seconds. So there are a few ways that we can go about solving this. You can solve it by factoring, and you can solve it using the quadratic formula because we are in standard form. Guys, this one's really relatively easy to factor, so I'm just going to go ahead and factor it. So I've got h of t equals negative 16t squared plus 12t plus 40. So I know I've got to look for a GCF, A value, B value, C value, A times C, and B. So I've got to make my T chart. First thing I always look for is a greatest common factor, and in this case, we have a greatest common factor of 4. So I'm going to divide a 4 out of each of these. I'm going to go ahead and take a negative 4 because we do have a negative initial value. So I'm going to take a negative 4 out of each of these. Because of that negative initial value, also, go look at the sketch real quick. Notice that the parabola is not facing upward, so I'm not shooting this off anywhere. And think about gravity. So when I shoot something out of a cannon, it's not going to go and rise into the air, but instead it's going to fall and hit the ground. So our parabola is facing downward. So we have a downward facing parabola. So that is why I have a negative initial value. So I'm going to factor out that negative 4. And then that's going to mean that my function is going to look like negative 4 multiplied by 4t squared plus 3t, minus 3t minus 10, where I now have an A value of 4, a B value of negative 3, and a C value of negative 10. So I have to find two numbers that multiply to negative 40, but add to a negative 3. So let's see, I've got 1 times 40, 2 times 20. 3 is not a factor of 40, but I've got 4 times 10, 5 times 8, and then we'll be back to 8 times 5. But I know that they need to multiply to negative and add to negative, so my larger factors are going to be negative. And the only factor pair that adds to a negative 3 is going to be 5 plus negative 8. So I'm going to break down that negative 3t into 5t minus 8t. And I've got 4t squared minus 10. I'm now going to factor by grouping. I'm going to factor out a t from my first grouping. So that'll leave me with 4t plus 5. And I'm going to factor out a negative 8 from my second grouping. Or excuse me, not a negative 8. A negative 2 from my second grouping. Which is going to leave me with 4t plus 5 again. So my factored form here is h of t equals negative 4t plus 5, and then t minus 2. Now I can actually solve for those values. So I can set each of those factors equal to 0. I know 0 can't equal negative 4, so I can do 4t plus 5 equals 0. If I subtract 5 from both sides, that gives me that 4t equals negative 5. And if I divide by 4 on both sides, I get a time of negative 1.25. So I can't have a time of negative 1.25 seconds. So I know that that is not going to be one of my solutions. But if I solve for the other one, I've got t minus 2 equals 0. I can add 2 to both sides. And I got a time equal to 2 seconds. So it will take 2 seconds for the cannonball to hit the ground. Sorry about that, guys. So it's going to take 2 seconds for the cannonball to hit the ground. And there is only one valid solution because time cannot be negative. So here's what I want you guys to do. I want you guys to practice the next one. You can use the quadratic formula to solve. You can use factoring to solve. Use whatever method is best for you. And we will go over it in the next video.